like a minute or so. Go live. And I'm live. Yes. Okay. Today, the main focus is going to be on word problems. And again, I know how much you all love word problems. For those of you in the chat right now, in the stream on Google Classroom, there should be a PDF file that I posted for cohort 1 yesterday. And that PDF file should look something like this. You should be able to click that and open it up. Everyone here in the classroom has a physical copy of said worksheet, but this is the worksheet that I'm going to be working off of today. So if you can't see the words on the board, because I'm going to put it up here eventually, but if you can't see the words on the board, that PDF file should have all of the word problems right there for you. Just go to Google Classroom. It should have been posted in the stream for cohort 1 yesterday, but you should be able to find it very easily. I know what you guys do with word problems. I know exactly everyone's mindset with word problems. When you look at a word problem, you typically just kind of skim because you don't like words. You skim and you look for numbers and you kind of hope for the best. Is that fair? I don't know. People give me all sorts of reasons why they hate word problems. Mainly it's because they don't want to read the problem. I'm like, oh, that's a little bit of a problem. Have I told you my sandbox example? No? No? Check this out. Imagine that you are a 6-year-old kid. You go to the park, and there's a sandbox. And you look at that sandbox, and sitting right on top of the sand is a quarter. What do you do? What do you do? You would do nothing? You walk up to a sandbox, there's a quarter sitting on top. What do you do? Sure. You're a 6-year-old kid. You want that quarter, don't you? Of course you do. What 6-year-old would not pick up that quarter? I went down to the teacher's lounge the other day. It's a habit of mine. I always check the change thing in the vending machine. You know what I'm talking about? I found 75 cents. Oh, happy day for me. Just saying, you take the quarter. Now, the next day, you walk up to that sandbox. You don't see anything, but somebody tells you there is a quarter buried in the sand. Let's say there is. Let's say there really is a quarter buried in the sand. You just can't see it. So you walk up to that sandbox and you're like, heck yeah, I'm going to get that quarter. So you look at the sandbox and you do this. I couldn't get the quarter. I couldn't get it. I can't reach. I can't. What am I doing wrong? I'm trying. I am trying. Look at me. Ready? I couldn't get it. I'm totally trying. Ooh. Is that necessary for getting this quarter? Logically, yes. When it comes to math problems, high school students are afraid of getting their hands dirty. They look at the problem and they hope and they hope and they hope that it will make sense. And they hope that something will just pop out and allow them to get the answer. That is not how math works. With mathematics, you have to figuratively get your hands dirty. You have to dig into the problem. You have to move some things around in order to get to the answer. I love anecdotes like that. It's not even an anecdote. I don't even know what to call it. A fable? Anyway, ladies and gentlemen, the goal of today is to work on this worksheet. There are some problems that I'm going to go over with you. There are some problems that I'm going to ask you to do on your own, and then we will review them. I'm going to try and get through as many as possible. On the project that I have assigned you, there's a project on Google Classroom. I don't know if I mentioned that to the people in the live stream. Obviously, I mentioned that to you guys, but in the live stream, there is a project. That project is not due until October 9th. But that project has an explanation to go along with it. But not all word problems are created equal. Not all word problems have the same approach and the same strategy. You have to face each word problem as if it were its own unique butterfly and attack it. I don't know if you've ever attacked a butterfly. They're quite intimidating. Anyway, let me bring up the screen. There we go. And let's get this thing started. Click. Zoom. Now, like I said, Some of these problems I'm going to go over with you with a fine-tooth comb. Some of these problems I'm going to get started with you and then allow you to complete them on your own. We're going to see what happens here. Let's read this first problem. A plot of land for sale has a width of X feet and a length that is 8 feet less than its width. A farmer will only purchase the land if it measures 240 square feet. Okay? What value of X will cause the farmer to purchase the land? Again, a reminder to those of you in Google Classroom, I probably could like copy and paste the link actually in the stream. Yes, there it is. Attached is the PDF. Copy the link, throw it into the chat, paste, boom. So now in the chat, you have the link to get directly to this PDF. Anyway, different strategies for different problems. For this problem, your best case scenario, draw a picture. Now, for this problem, unfortunately, it didn't mention what type of shape it was. It did not mention what type of shape it was. It just mentioned length and width. Could you guess what shape it may be? Yeah, which is? I would say rectangle. Square would be all equal sides. Definitely a rectangle in this case. So I'm just going to draw something. Let's just see what happens. I'm going to just draw something. Let's just draw a rectangle. Okay, oh, happy day. Sometimes drawing a picture is in your best interest. Cool. Oh, quick side note before we continue with these problems, because you reminded me with your notebook there. You choose where you want to put this information. You can put it in your notebook. You can put it on the worksheet. That's up to you. I'm just going to caution you that the worksheet may not have enough room for some of the problems. Just a heads up. Okay. I'm going to have to label some junk out. Okay. Width, length. Okay, cool. I'm going to label this side X. And it says a length that is 8 feet less than the width. Taking a problem and turning it into an image. Length and width. How does one calculate the area of a rectangle? Yeah, that's like geometry 101 stuff. Actually, you learned that way before geometry, right? Yeah, really? Wow. I know my kid's in first grade and he's not there yet, but whatever. Maybe. Length times width should give you the area, and lo and behold, they tell you that the land measures 240 square feet. 240 square feet. What's interesting about like units, just as like a quick side note in terms of like word problems, when they talk about units, like feet, for example, move this. You might see something as like feet. You might see something as like feet squared. You might see something as feet cubed, which are all entirely legitimate measurements. Whenever you see something of just feet, it's talking about a one-dimensional measurement. A one-dimensional measurement, basically like a length. Think of like a number line. The length on a number line. Could be length, could be width, could be height. But if you see just feet with no exponent on it, it's just a one-dimensional thing. Whereas feet squared, all of a sudden, is a two-dimensional thing. Anything unit squared is typically talking about area. It is talking about the area of something, like the area of a rectangle. If I'm talking feet cubed, I'm no longer talking about area. If I'm talking about feet cubed, what am I talking about? Talking about volume. Yeah, just keep that in mind. Feet squared is talking about two dimensions, maybe length and width. Feet cubed could be talking about 3 dimensions, length, width, and height. You ever just sit in a class and draw cubes? Some people know what I'm talking about. You know, I'm just saying. It's just fun to kind of do that kind of stuff. Cubes, 3 dimensions. Anyway, just as a reminder, because some of these problems are going to throw various things at you. And when they say 240 square feet, you are talking about area. And as you told me before, length times width gets you area. I'm kind of going through this again with a fine-tooth comb because I'm trying to get you used to word problems. I know at this point, word problems are like, you don't even want to think about them. Word problems send shivers down your spine, but I'm trying to remove that stigma. Okay. I got to solve this. I got to get x by itself. Crap. There's a bunch of different things I can do. But you need to simplify. Simplifying is usually a good idea. But Mr. Markey, I don't even know what to do. Just try some stuff. Try it. See if it works. I'm going to simplify just to see what it looks like. I don't know what it's going to look like. I don't know what any of these answers are going to be. Let's just see what happens. The best part about math, in my opinion, is just seeing what happens when you try something and not being afraid of the consequences. Now I have something that kind of looks like a quadratic. It kind of looks like a quadratic. I mean, I got the x squared in there. For the most part, it is a quadratic. Now I got to solve this thing. We have been solving by factoring. The past 2 weeks, we've been focusing on factoring quadratics and solving quadratics by factoring. So what do I do first? You didn't fall for my trick. You know what most people say? When I say to people, what do we do first? They act like robots. And they're like, step 1, GCF. And I would say, nope. But you said exactly what we need to do. We need to get one side equal to 0. He said, subtract the 240. The only way that you are going to even begin using the Tucker method of solving quadratics, you need to get one side equal to 0. You have to. You absolutely have to. Then you would go through the Tucker method. Step 1, GCF, which in this case, because it's a 1x squared, the GCF is 1. I can't do anything. Move on to step 2. Step 2, A times C will get me negative 240. Ugh, negative 240. What a wretched number. That's okay. Let's see what happens here. I got to find two numbers that multiply to negative 240 and add up to negative 8. All right. Negative 240 divided by 2. Nope. Negative 240 divided by 4. Nope. Negative 240 divided by 6. Nope. Negative 240. Let me just jump to 10. 10. No. Negative 240 divided by 12. Huzzah! It's got to be 12 and negative 20. It's got to be a 12. It's got to be a negative 20. Negative 20 because it has to add up to negative 8. I'm going to skip the t-chart. You could do the t-chart here, but you really don't have to because it's a 1x and a 1x. It won't simplify. But ultimately, I'm going to get x plus 12 and x minus 20 equals 0. I get two answers. You set each of those equal to 0 and solve. You're going to get x equals negative 12 and x equals positive 20. Now again, notice I have not circled anything just yet. I've just gotten my two answers. Both answers, negative 12 and positive 20, they work in the equation. But this is going to be a common theme today. Do they work in the context? In the context of the problem. The context of the problem is what makes all the difference in the world. You're talking about a farmer measuring X feet by X minus 8 feet. He wants to purchase the land. It has to measure 240 square feet. What value of X will cause the farmer to purchase the land? Has to be the 20. You can't have a negative measurement. You can't have negative 12 feet. That doesn't make sense in the context of the problem. Sometimes an answer will automatically be eliminated, not just because it's negative, but because it doesn't make sense in the context. Sometimes both answers might work. In this case, they didn't, but sometimes both answers could work. It's got to be 20. It's got to be 20. Now you go back and you read the question and you have to then answer what they were asking for. Oh no, my microphone. Ultimately, the answer would be x equals 20, and I'm going to give a little bit extra here. It's 20, but then it would be measured 20 feet by 12 feet. I would get that because I would plug the 20 in for the x. The dimensions of the plot of land would have to be 20 feet by 12 feet. And it fits all the criteria that he was looking for. It fits the criteria of the length being 8 feet less. It fits the criteria of 240 square feet. It fits everything we're looking for. I love word problems. Okay. Number 2. Now, I'm going to set up number 2 for you, but then I'm going to have you finish it. I'm also going to have you do number 4, but we'll get there in a minute. Let's read number 2. In business, a break-even point is the point x, y, at which the graphs of the revenue and the cost functions intersect. For one manufacturing company, the revenue from producing x items is given by the function y equals 2x plus 12, and the cost of the producing x items is given by y equals negative x squared plus 10x plus 5. Find all break-even points. Be honest. At what word did you stop listening? At what word did you stop listening? That's usually what happens to a lot of people. Yesterday, somebody told me they stopped listening at the word business, which I thought was pretty funny and honest. These word problems, these are the types of word problems that people look at and they literally think to themselves, this is why I hate math, is what they think to themselves. This is why I hate math. Problems like this junk. No, but let's break it down piece by piece. Now, first of all, a break-even point is when these two graphs intersect each other. Okay. The revenue is given by this. Okay, it's a linear equation. The cost is given by this. It's a quadratic equation. And they want to know, where will these two equations cross each other? Where will these two equations intersect? Ooh, let me rephrase that one more time. Where will these two equations be equal to one another? Be equal. Break even. Revenue equaling cost. Here's the setup. And again, I'm going to set this up. I'm eventually going to have you do it on your own. Here's the setup. 2x plus 12 equals negative x squared plus 10x plus 5. That is the setup to this problem. They want to know, where's the break-even point? Where will these two graphs intersect? When will these two equations be equal to one another? That's the setup. You got to get one side equal to 0. I'm going to strongly suggest that you move everything over to the left so that you make it a positive x squared. That is in your best interest. And then you would begin solving it. You're going to get 2 answers. And both answers work. Now, here's the other thing that I'm going to have you do in a moment. I'm going to have you do number 2. I'm going to have you do number 2. I am also going to have you do number 4. I'm going to skip 3. We'll do number 3 together. So right now, take the next little block of time, maybe 5 or so minutes. You in the chat do the same thing. I'm going to have you do number 2 and number 4. Reminder in the chat, if you need the PDF, I put the link into the chat so that you can easily just click and get to the PDF of the question so you don't have to strain your eyes looking at the board. Take the next 5 or 6 minutes. Let's go. There we go. 2 and 4. We'll do number 3 together, only because there's a certain strategy that I want you to employ for number 3 that I'm not sure many of you know about, but we'll talk. Now, if you got number 2 done, fantastic. If you started number 4 but didn't get it finished, that's okay. I want to see, my main focus was number 2, and then I want to talk a little bit about number 4. In business, we're talking about the idea of break-even points, where these two graphs cross each other. Let me show you something real quick, actually. Let's go to Desmos. I love me some Desmos. Graphing calculator. Let's go y equals 2x plus 12. I'll have to zoom the thing out a little bit. Let's go y equals negative x squared plus 10x plus 5. There we go. Now you can't really, oh, there you go. Now you can see a little bit better. Look at that graph. Look at that wonderful graph. There are two what they call break-even points. where the linear equation and the quadratic equation cross each other. And clearly one of them looks about here-ish and one of them looks about here-ish. There are two answers to this problem. Two answers. Two break-even points, if you will. Now, yes, you could guess and check. Of course you could guess and check, but life is not always guess and check. Sometimes guessing and checking will take forever, especially if the answer is a decimal. In this case, it's not a decimal, but if it were a decimal, you'd be guessing and checking forever. So instead, we focus on the solving techniques that we have been focusing on, which in this case, bring this back, click, is got to be the Tucker method of factoring or whatever method of factoring that you know. Did I tell you what the principal did to me last week? I was teaching a lesson. I think it was like Wednesday or Thursday. I haven't told you that yet. Now, I was teaching, and the new principal is standing at the door, just looking in the classroom with the two vice principals, just watching. And I noticed them at one point, and they all kind of like look at me, and they're like thumbs up, kind of wait, whatever. And they want me to continue teaching. And I'm like, okay. So I continue teaching my lesson. And then at one point, I just look at them and I'm like, I'm sorry, it's very awkward. Like it's very awkward to continue with you guys just standing in the door through the glass. So the principal walks in the room, sticks his head into the live stream camera, waves, and then walks out. I've never met this guy before this school year. You guys probably already know him from middle school, maybe? Yeah. He's nodding yes. The rest of you are like, what, Mr. McGee? No? All right, you guys are weird. But yeah. I don't know what kind of principal he's going to be, but that seemed a little weird to me. Anyway, back to this. I'm just venting. I'm going to add an x squared. I'm going to subtract a 10x. And I'm going to subtract a 5. Because I got to get one side equal to 0. Cancel that, cancel that, cancel that. I'm going to get an x squared minus 8x plus 7 equals 0. That is the quadratic that I need to work with. That quadratic is not obvious at the beginning. It is not obvious at the beginning, but it's a matter of finessing the problem. Figuring out, first of all, what the question's even asking, and then number 2, making an attempt at moving some things around. That's what's going to happen with this project that you guys are going to have to get done for me. You're going to have to finesse some of these problems. Now, I take that quadratic, and I'm going to begin solving it by factoring. So, A times C is 7. Interesting. I got to find two numbers that multiply to 7 and add up to negative 8. I got to find two numbers that multiply to 7, positive 7, and add up to negative 8. How is that even possible? Think about this logically for a moment. Two numbers that multiply to a positive and add up to a negative. What should both numbers be? They should both be negative. Negative times a negative would give you that positive. A negative plus a negative will give you a larger negative. What are my numbers? Has to be negative 7 and negative 1. It has to be negative 7 and negative 1. They multiply to give you positive 7. They add up to negative 8. The t-chart won't do anything because it's a 1x and a 1x. So it's x minus 7, x minus 1 equals 0, giving me an answer of positive 7 and positive 1 when I set each of these equal to 0 and solve. Interesting. I got me two answers. But now keep in mind the context of the problem. I said this was going to be a recurring theme. The context, the context, the context. Yeah. I got a highlighter just for this. Ha ha. The point x comma y. The point x comma y. Meaning, Yes, I got x equals and x equals. There's nothing's going to change that. Plug the 7 back in here. When you plug 7 in for x right here, you get 2 times 7 plus 12. What is 2 times 7 plus 12? Come on, you can do that in your head. 2 times 7 plus 12. I hear crickets. I stepped on a cricket yesterday. They look really gross. It's like they have extra legs. What's 2 times 7 plus 12? No one wants to say. 26. Yay, we did it. Yay. No, but that's the context of the problem. Take the 7, you plug it in, it gets you 26, which means this is one of my break-even points. You take the 1, plug it into the equation, 2 times 1 plus 12, that should give you 14. 1 comma 14 is the other break-even point. See, again, I'm only basing this on the context of the problem. I am only basing this on the context of the problem. The problem, what I highlighted up there, they said a break-even point was an x comma y point at which those functions intersect each other. Let me go back to Desmos. If I go back to Desmos, look at this. Click, click. I just highlighted the 2 points of intersection on Desmos. It's the exact points that we came up with. Now, clearly, you could have just gotten that from Desmos, but again, I need to see the work. And this is the appropriate work to get that thing done. You guys ever seen cicada shells? Cicadas. Yeah, cicadas are amazing creatures. They lay dormant under the ground for either 13 or 17 years, and then they come out to like kind of shed their shell and reproduce and feed. So my son, he has a fascination with cicada shells to the point where, if I could find the picture here, to the point where he like finds them in the backyard and then poses them for some reason, like poses them, and I have to take pictures. So here he took some cicadas and like made it into like a wrestling theme. It was like super funny. So then my wife sends me a picture that she found on Facebook, and it was called. Well, it's not. I'll show you what it's called. It was. We don't know who this kid is. We don't know who this kid is. But it was basically like pictures that parents share with pictures, and it was a kid who like made a cicada army. Have you? Yeah, cicada shells are all over the place. I don't know why. That was just on my mind because I was thinking about squishing a cricket. Anyway, number 4. I asked for you to do number 4 as well. I'll talk about number 3 in a moment. If the measure of one side of a square, now a square is originally going to be all same sides. One side is increased by 2. The adjacent side is decreased by 2. Okay, hold on. Let me draw this. Originally, it's like x by x. But one side was increased by 2. And one side was decreased by 2. Okay. And the resulting area is 32 square centimeters. This is kind of like number 1. Kind of like number 1. With a little bit of a twist. Length times width gives me area. That's the setup to this problem. The thing with word problems is they're not going to tell you how to set this stuff up. They are not going to tell you precisely what to do. They are simply going to imply what to do based on the context of the problem. That's what people hate about word problems. That's what I love about word problems. The fact that there's no one-size-fit-all way to solve a problem like this. It's more along the lines of interpreting what they give you because they've given you just enough information in order to get this problem done. Now, the original square, I have no idea what the original square is, but the original square would look like x by x. Like if I just draw this over here, come on, a little marker. The original square is like x by x because the square has all four sides equal to each other. As long as I figure out what x is for this problem, that is going to answer the question, find the measure of one side of the square, or the original. Again, we could totally guess and check, but that's not what I'm looking for. I'm not looking for guessing and checking. I'm looking for actually solving. We're going to multiply this junk together. Oof. I showed you this a while back. Let me zoom in a little bit so you can see it. I showed you this a while back, but you could multiply these together by doing this. You could. I don't know how many of you actually learned. Did any of you learn FOIL in Algebra 1? First add or enter last? I hate FOIL. The what? Yeah, it hurts my teeth. Just saying. Don't. It works mainly when you have like a binomial times a binomial. Then you could use FOIL, first add or enter last. But it doesn't work if you have something larger than this, like a trinomial, which we will get to in the next chapter. But I got to multiply this junk out. X times x is x squared. I get a 2x here. I get a negative 2x here. And I get a negative 4 here. And now I got to combine me some like terms. Ooh, goodness gracious. Let me zoom in a little more. Zoom in, zoom in, zoom in, zoom in. What the heck happens here? Look at this. I got a 2x here and a negative 2x here. What happens when I try to combine those like terms? Heck yeah. So I'm going to get an x squared minus 4 equals 32. Oh, I realized the people at home couldn't hear what you were saying. She said that they canceled each other out. And I said, heck yeah. And then we high-fived. But it was at a distance, so don't worry. I got them. So I got to solve this thing. Once again, get one side equal to 0. Subtract the 32. X squared minus 36 equals 0. What is so weird about that? There's my quadratic. There's my quadratic equal to 0. But what's so weird about it? Something's off. Something's missing. What's my b value? You said no b. What's my b value? That's me having a heart attack. What's my b value? 0. You said there was no b. It's 0b. Or I'm sorry, 0x in the middle. The b is equal to 0. There's no x in the middle of this term, so it disappeared. See, originally, come here, microphone. Originally, this is an ax squared plus bx plus c. That's what it was originally. But because the b value is equal to 0, that causes this middle term to just go away. 0 is a very strange number. How many sides are there to a circle? Would you believe me if I said there's an infinite number of sides? You know why? Think of a square. It's got 4, right? Pentagon, hexagon, heptagon, octagon, nonagon, decagon. Keeps going up and up and up and up and up. The more sides you add, what shape does it start resembling? A circle. If you had an infinite number of sides, it'd be a circle. I love 0. 0 is a great number. People often forget it as a number. So, the reason why I bring that up, besides dropping my pen and looking like a fool, A times C is negative 36. That's what you did? That's exactly what you should have done. Because now, the reason why I'm making a big deal about the b value is because these two magic numbers have to add up to 0. They have to. That's why there's 6 and negative 6. They have to add up to 0. They have to add up to that b value of 0. They have to multiply to get you negative 36. meaning I got me an x plus 6 and an x minus 6 equals 0. Again, 1x and 1x, because it was a 1x squared. I get answers of -6 and I get an answer of +6. The only answer that works is that positive number. +6. +6 what? It's a word problem. +6 what? Oh, Miss Murky, I don't want to have to reread this word problem. +6 what? Careful. It is just centimeters. The reason why goes back to my talk about squared and cubed and junk like that. If you tell me square centimeters, ladies and gentlemen, if you tell me square centimeters, then I'm assuming area. But this problem just wanted the measure of one side of the square, just one side of the square. And that one side of the square would be 6 centimeters. It's very strange. Can't wait to get into like dimensional talks and things of that nature. I don't even think we will. I love dimensional talks. Do you know what the fourth dimension looks like?
Is it like a tesseract or something? Like I see like through it.
Kind of. Think of it this way. Think of it this way. That's a cube, right? Well, I drew it on a flat surface.
Yeah,
right?
see all of them at once.
Kind of. Think of it this way. This is a 2D projection of a three-dimensional object. It's a 2D projection of a three-dimensional object. A tesseract is a 3D projection of a fourth-dimensional object. We're seeing a three-dimensional object even though it's on a 2D surface. A tesseract is seeing a fourth-dimensional object, but it's within a 3D world. It's very strange. You guys ever heard the book Flatland? Flatland? Nothing? Flatland's a great book. It's an old book. It's about math. It's about a story of people who live in a two-dimensional world. They live in a flat world. And then all of a sudden, their world is interrupted when a three-dimensional object goes through it. It's like a basketball. Think of a basketball going through a piece of paper, right? Or think of a basketball going through the surface of like a pool or something like that. First, it starts out as like a little dot, and then it expands as the basketball keeps going through. And then as the basketball leaves the world, it goes back down to being an infinitely small point and disappears. And they're like, what the crap was that? We've never seen anything like that before. Some people think fourth dimensional objects could be ghosts. Whatever. Anyway, back to number 3. Number 3, I had you skip. The reason why I had you skip number 3 is because I wanted to talk you through what a proper strategy would be. So, they want you to find 2 consecutive positive integers such that the square of the first decreased by 17 equals 4 times the second. What the heck? Here's what you do. 2 consecutive integers. 2 consecutive integers. Let me label the first one as x. What should I label the second one as? If I label the first one as x, because they're 2 consecutive integers, I can label the first one as x, and I can label the second one as what? No, I'm not even there yet. Ignore all of that stuff right there. I'm just talking about the 2 consecutive integers. I labeled the first one as x. What's the second one? Ooh. Huh? You could pick another letter if you wanted to. Some people would say Y. Some people would pick some random letter. I don't want to do that. Check this out. There's the second one. Give me a random number, any number. Give me a number.
4.
What's the next number?
5.
Okay, those are 2 consecutive numbers, correct? There are 2 consecutive numbers. He said 4 and then 5. 2 consecutive numbers. If x was equal to 4, wouldn't I have also plugged in a 4 right here and get 5? Yeah. x and x plus 1, they represent two consecutive numbers. That's the strategy that you didn't know. That's the strategy that you did not know. If you ever want to express consecutive integers, you could express them something like this. It really is wonderful. And by doing that, now I can go ahead with the rest of the word problem. Such that the square of the first decreased by 17 equals 4 times the second. There is my problem. The square of the first decreased by 17 equals, and I circled it or put a square around it so you could see equals, 4 times the second. There is my problem. I love me some word problems. Word problems, in my opinion, are like a puzzle. It's a puzzle. I love puzzles. I love all kinds of puzzles. I love the kind of puzzles that just get you so frustrated you just want to throw them against the wall, but then you pick it back up because you're like, nope, I got to solve this thing. It told me. The square of the first. I know, that's what I'm saying. Like, it takes a little finessing, you know? I love that kind of stuff. I was in college, and I was taking this class called Number Theory. Great class. And at the end of the we took a test one day, and at the end of the test, there was an extra credit problem. And no one could figure out what the extra credit problem was. Mind you, I had like an hour to get this test done. I got the test done in 15 minutes. I got 100. Yeah. I got it done in 15 minutes, and I spent the last 45 minutes working on this extra credit problem, and I couldn't figure it out. But no one else in the class could figure it out too. So I took a picture of the problem, and I took it back to my dorm. And I worked on that problem for the rest of the weekend, because it was a Friday we're taking the test. I worked on that problem almost all of Saturday and almost all of Sunday. Yes, I could have Googled the answer. I didn't want to because I needed to figure it out by myself. So Monday morning, before my class, I walked into my professor's office. I had 8 pages worth of work with the answer proven in 2 different ways. And I took those 8 pages and I tossed it at him. And I said, there you go. And he looked through it and he's like, oh, you're correct. I'm like, you're darn right, I'm correct. And then he proceeded to show me how to do it in 3 seconds. And somebody might be like, Mr. Markey, you wasted your whole weekend. No, I don't care that you can do it in 3 seconds. I figured out how to do it my way.
You did.
Yes. It doesn't matter if it was 2 days. It doesn't matter if it was 2 seconds. Think about somebody who can run a marathon in 2.5 hours. That's pretty world class, right? Doesn't matter if you can run a marathon in 2.5 hours or in 10 hours. Regardless, you ran a marathon. I love math. X squared minus 17 equals 4x plus 4. I had to distribute that 4. Now I got to move everything over because I got to get one side equal to 0. X squared minus 4x minus 21 equals 0. This is the process that you would then go through. You'd have to solve that garbage out. Factor, using that Tucker method once again, you end up with x, I'm going to skip ahead a little bit, x minus 7, x plus 3. To recap why that is, again, negative 7 times 3, negative 7 plus 3. The only reason why I can skip the t-chart, is because it's a 1x squared. I get an answer of 7, and I get an answer of negative 3. Which one works? Which one doesn't work? Which one works? Which one doesn't work? I get 2 answers. Which one actually is my answer? Ooh, word problems. Gotta look back at the context of my problem. Which one works? Why? It says positive. That is the wonderful thing about word problems. Sometimes they hide it right in the problem itself. The only reason why 7 works is because they said positive. But here's the thing. I'm going to be completely honest. For this problem, if this were like a test or a quiz or some junk like that, and you just wrote down 7, I'd mark it wrong. Because the problem wanted you to find the consecutive integers, which means the answer is not just 7. The answer is 7 and 8, which is 2/3 to a hilarious joke. The answer is 7 and 8, 2/3 to a hilarious joke. Come on, somebody get it. 7, 8, 9. Hilarious. You know what that's called? That's called the knee slapper. All right. Now, I'm hyped. Okay, let's jump to number 6. Let's jump to number 6. My goal is to get through number 5. Number 7's a little bit of a challenge, but I'm going to leave that. I don't put challenge problems on my assessments, but I want to talk about number 6. Let's talk about rocks falling. There's some dude. Where's my green one? I need my green marker. I had it on me the whole time. There's some dude standing on the top of a cliff. There's your cliff. And there's some dude. And he throws a rock. Boom. Smash. Blood everywhere. The height of a rock thrown off a cliff can be modeled by that equation. H equals negative 16t squared plus 8t plus 120. Where h is the height in feet and t is the time in seconds, how long does it take for the rock to reach the ground? What's the height of the rock when it hits the ground? What's the height of the rock when it hits the ground? Because it's on the ground. Yeah, exactly. It's on the ground. So, if the height of the rock is 0 when it hits the ground, this is not my equation. This is my equation. 0 equals, and not h equals. By the way, you see how I write my t's? See how there's like a cute little tail on the bottom of the T? Do you know why I do that? Exactly. It's a good suggestion. It's a very good suggestion. If you don't want your T's to be confused with plus signs, just put little cute tails on them. I learned to do that in college for funsies. All right. We got to solve this thing. It's equal to 0. Let's start with the GCF. Greatest common factor. What's my GCF? Ms. Markey, it looks like they could all be divided by 2. Yes, they can. But that's not my GCF. What's my GCF? 8. Now pause for 1 second, though. Yes, it's 8. I agree with you. GCF is 8. Yes, it's 8. But you need to do yourself a favor. You need to give yourself some hope. You need to give yourself an easy way to get this problem done. Yes, 8 is the greatest common factor, but here's my suggestion to all of you. Don't take out an 8. Take out a negative 8. The reason? If you take out a negative 8, it will make your A value positive. I don't know why I was walking over here. I should be walking over there. Take out a negative 8. If you take out a negative 8, it will make your life at least 100 times easier. Oh my goodness. So let's see. 2t squared minus t minus 15. Trust me, those numbers work. You want your A value to be positive. If you get that A value to be positive, again, life is easier in terms of getting this problem done. That -8 that you just took out will not affect your answer. That -8 will not affect your answer. It won't. But let's get this thing done. Let's see. A times C is -30. Oh, I need two magic numbers that multiply to -30. Yeah? They'll work. Why do they work? They multiply to -30.
Because the -6 bigger, so we add them together, we equal -1.
Exactly. Add them together, you get -1. Exactly. You got to make sure that negative is on the right side. Now here, I have to do a T-chart. You got to do a T-chart here. You got to do a T-chart here. 2T and 2T go into the top. You got to do a T-chart here. 5 and -6. Absolutely yes. Simplify 2 over 5. You can't simplify 2 over 5. 2 over -6. Yes, I can do that. I get you a 1. That gets you a 3. So I get a 2t plus 5 and a 1t minus 3 equals 0. Now, the -8, you could bring down the -8 if you wanted to, but I'm telling you right now that -8 will not affect the solution. That -8 will not affect the x-intercept. That -8 will not affect the 0 of the function. You get two answers. You solve this one, subtract 5, divide by 2, you get -2.5. You solve this one, you get 3. Which one is my answer? Context of the problem. Which one's my answer? How long does it take for the rock to reach the ground? What's my answer? She stole your thunder. That's okay. 3 seconds, though. Yes, the answer is indeed 3 seconds. Why? Now, by the way, I'm going to write the word seconds. I'm going to write the word seconds here and circle this because, yes, this is indeed my answer. Why am I ignoring the -2.5? Do you know? Well, I mean, it kind of can be, but there's something a bit more like less scientific about it. Yeah. What? Less scientific about it. Now, what I'm going to say is going to make perfect sense, and it's going to be like you're going to think to yourself, it's kind of what I said. Yes, I agree wholeheartedly. And if you said that, I'd give you full credit. He's throwing the rock forward. He's not throwing the rock backwards. The reason why that other answer shows up is because of this parabola. This would be -2.5, but he's not throwing it that way. Time can't go backwards. Yes, time, and I'm talking about like negative, but time can't go backwards. You can't reverse time. Did you know I can time travel? I can time travel into the future. Ready? I'm going to move 1 second in the future. Done. I did it. Aren't you impressed? Just saying. Yeah. You have Gettys. Nice. When are you going to see him again? Okay. Please remind yourself. When you see Mr. Gettys, tell him, congratulations on finishing in 3rd place. He'll know what I'm talking about. Congratulations on finishing in 3rd place. Anyway. All right. I have a few minutes left. Let me tell you. I'm going to do 2 things. No, 1 thing, but whatever. Number 7's a challenge. I would not give you a challenge on an assessment. You can try that one on your own. It has to do with area and perimeter, but I'm not going to go over that one today. Number 5, I want to set up for you. I want to set it up for you, but I'm not going to be able to finish it. The video that I made in regards to the project has a very similar problem that I go over with you in regards to a garden with a walkway around the outside. You can look at that video when you are beginning to do your project to help, because believe me, it will help. But I want to help you set up number 5. Now with number 5, ladies and gentlemen, yes, it's a rectangle, but it's a rectangle inside of another rectangle. A rectangular pool is 20 feet wide by 50 feet long. The pool is surrounded by a walkway. The walkway is the same width all the way around the pool. The total area of the walkway is 456 square feet. How wide is the walkway? Now hold on one second. The area of the whole thing equals the area, I wrote the word area, I want to write the word pool, of the pool plus the area of the walkway. We know the area of the pool. We know the area of the pool is 1,000 because it's 20 by 50. The area of the walkway, they tell us, is 456. But now here's the catch to the whole thing. How wide is the walkway? I'm going to label the walkway X. I'm going to label the width of the walkway to be X in both directions. Now check this out. Watch me on this picture. In fact, I'm going to zoom in a little bit. Hold on. I'm going to erase this. I'm going to zoom in just a little bit. There we go. Zooming in, zooming in, zooming in, zooming in, zooming in. Watch this crazy crap. If I'm going to go the height, watch the height here. I go X, I go 20, and I go X. That's a 2x plus 20. Watch this width right here. Watch this width right here. X, 50, and X. There's a 2x plus 50 here. I'll zoom back out in a moment. Look at that little equation that I got going on here. Length times width will give me the area of the whole thing. Length times width will give me the area of the whole thing. Again, this is what I said. I was going to set this up for you. And then you can finish this on your own. You're going to get a nice answer about it. And you're going to have to do something like this on the project. But you're going to have to multiply these together. Perhaps use a box. Set it equal to 1,456. Get one side equal to 0. And then begin using the Tucker method. GCF, A times C, magic numbers, T-chart and simplify, writing your factors, and then ultimately getting answers. The answer should be a nice number. I can't remember if it's a whole number, but it should be a nice number. I love problems like this. Again, the video on the factoring project on Google Classroom, I have a video that shows a similar example using a garden. Watch it. Watch it, watch it, watch it, watch it. I give the explanation of the project, and then I go into a sample problem. If you have any questions, make sure you're emailing me. I'm expecting that homework to be done. I'm going to check those tomorrow. From the textbook, that is. I'm going to check those tomorrow. And the project, obviously, is an ongoing thing. Yeah, class should end now. Ha ha ha. Nailed it. Goodbye, those in the stream.